Tech thinking, we're switching on the mind. Math tech thinking, when numbers get refined. Welcome to Math Tech Thinking Foundation. Tune in, lock in, build your motivation. Step by step, we shape imagination. Math Tech Thinking, Math Tech Thinking Foundation.
Hello everyone and a very warm welcome to today's session. I am Dr. Mehar and it is my pleasure to introduce you to the fascinating world of machine learning. Let me begin with a short story. A few months ago, a student of mine said, "Sir, Netflix knows me better than my family. Every time he opened Netflix, it recommended exactly the kind of movie he liked, even one he had never heard of. This made him wonder, how is it able to learn and improve on its own? The answer lies in machine learning." In today's lecture, we will explore that machine learning is why it matters, how it works, and the three major types of the learning that machine use to make intelligent decision. Let's begin our journey. Machine learning is a branch of the artificial intelligence that allows computers to learn from the data and experience without being explicitly programmed. Think about how a child learns to identify foods. You show them several apples and oranges. After enough examples, the child starts recognizing them correctly. You don't write rule in the child's brain. They learn from pattern. Machine learning works in exactly the same way. Instead of programming structure manually, we give example large amount of the data and the machine learns the underlying pattern and relationship. For instance, examples, Gmail automatically detects spam emails. It learns from millions of examples of spam and non-spam email. It was not programmed with the manual rule for every possible spam message. This ability to learn from examples is the heart of machine learning. Now, why does machine learning matters today? Because the amount of the data we generate every second is massive. Photos, videos, online purchase, GPS location, sensor reading. No human can manually analyze all of this. Machine learning helps us understand this ocean of data. ML enables automation, prediction, pattern recognition, personalized experience, and faster, more accurate decision. Hospitals can predict disease outbreak using ML. Banks can detect fraudulent transaction instantly. Retail companies can understand customer behavior and optimize product. Social media platforms can identify harmful content. Machine learning is not just a technology, it is the foundation of our modern innovation. In fact, ML is everywhere in our daily lives. When your phone unlock using facial recognition, that is the example of the machine learning. When Google Maps predict traffic, or when Instagram recommend reels, that is also the example of machine learning. When Amazon or Flipkart suggest items for you by using the machine learning model. Even your bank alerting you about suspicious transaction is also the example of machine learning. You interact with the machine learning dozens of times every day, often without realizing it. To understand how ML works internally, let's look at its five essential components. The first component is data. The raw material for learning. Without good data, an ML model cannot perform well. The second component is the features. These are specific pieces of information extracted from the data. For house price prediction, which might be include size, location, number of rooms, and so on. The third component is the model, a mathematical structure that captures pattern in the data. Fourth is the learning algorithm, which trains the model by adjusting parameters based on the errors. Finally, inference is when the trained model makes a prediction on new unseen data. Let me give a simple analogy. Think of preparing a cup of tea. The ingredients are your data. The flavor like ginger or cardamom are the features. The recipe is the model. The cooking technique is the learning algorithm. And the final tea served is the inference. Just as tea quality depends on good ingredients and the right process, machine learning outcome depends on the data quality and learning technology. Machine learning can be broadly categorized into three types. First is supervised learning, second is unsupervised learning, and reinforcement learning. Each type resembles a different way human learns. Let's begin with the supervised learning. Supervised learning is the learning with the guidance of the teacher. We train the model using labeled data where both input and correct output are known. Think of a student solving question and referring to the answer key to learn. Gmail classifying emails on the spam or not spam is supervised learning. A doctor using the ML model to classify tumor from X-ray images is the supervised learning. Predicting the weather a customer will repay a loan. Forecasting rainfall rely on labeled training examples. Supervised learning is the further divided into the classification and the regression. Classification predict categories, for example, whether a patient has disease or not, or whether a transaction is fraudulent. Regression predict numerical values, for example, predicting the house price, predicting tomorrow's temperature, or estimating sales. If you want to predict whether a student will pass or fail, that is the classification. If you want to predict the student's exact mark, that is the regression. Next comes unsupervised learning. This is the learning without labels. The system must discover patterns on its own. Imagine you walk into a party where you know no one. After a few minutes, you naturally notice cluster, maybe students in one corner, families in another, professions are in another corner. Nobody labels this group for you. You discovered the pattern yourself. That is how unsupervised learning works. In the real world, unsupervised learning is used for customer segmentation, anomaly detection, organizing large document set, and grouping similar images. One of its main technique is the clustering, which group similar items together. Netflix uses clustering to group viewers into action lovers, comedy lovers, or romance lovers. Supermarket use clustering into group clusters into premium, budget, or the occasional shoppers. Another major technique is the dimensionality reduction, which simplifies a large dataset by reducing the numbers of features while retaining essential information. It is similar to the summarizing a long box into a short summary, only the core information is kept. Now let's talk about the reinforcement learning. Reinforcement learning is the learning through trial and error. Think of a baby learning to walk. The baby takes a step, falls, try again, adjusts the balance, and eventually learns. Nobody gives the baby labeled data. The learning happens through experience. This is exactly how reinforcement learning functions. It is widely used in the robotics, self-driving cars, game playing AI, and optimizing traffic signals. In reinforcement learning, we have an agent that interacts. The agent takes action, receives reward or penalties, and learns the best strategy over time. It is very similar to playing a video game. Your moves are actions. The game world is the environment, and your score is the reward. So here, this is the algo. On the left hand side, you can see the raw input, and in the middle we have the environment and the agent. Agent will select the algorithm and reward state best according to that, and we have the output on the right hand side, as you can see in this model. Beyond this, we also have additional paradigms such as semi-supervised learning, which uses a small amount of the labeled data along with a large amount of unlabeled data. Self-supervised learning, where the system generates its own labels. This is used heavily in the modern language model. And deep learning, which uses layers neural network to extract complex patterns. Deep learning power facial recognition, speech assistance, large generation, automation, driving car, and many AI applications that we rely on today. To summarize everything we covered today, machine learning allows the system to learn from data and experience. Supervised learning learn with example and labels. Unsupervised learning discover patterns without labels. Reinforcement learning learns through reward and interactions. Additional paradigm like deep learning expand the capabilities of machine learning even further. Understanding these foundations idea is essential before moving into the algorithm, neural network and real world machine learning development. Thank you very much for attending this session. I hope this lecture has helped you develop a strong and intuition understanding of the machine learning concept. I look forward to seeing you in the next session where we will explore more advanced ML techniques. I am Dr. Mehar. Feel free to reach out anytime. Have a wonderful day. Thank you.
Math tech thinking, we're switching on the